tonight, guys. Last one, and I really appreciate it even more tonight that you've sacrificed the weather to come here as well. Who knows how long this weather's going to last for? So what I've promised is that we'll get through this as quickly as possible so that you can go and enjoy the sunshine. So, but thank you very much for coming. Biscuits, as normal, are there waiting for you. And also, I've got some example questions from year 1 straight through to year 6, division questions, which you can test your newfound skills and knowledge on at the end afterwards if you'd like to take some away. So, as normal, the purpose of our tutorials and our workshop tonight is to delve deeper into our new calculation policy that was created in October, to show how division skills are taught across the prep school from EYFS straight through to year 6, and also, most importantly for yourselves and for your children, is to improve confidence in being able to help them at home, in terms of your children being more secure with their knowledge and understanding. And for those of you that haven't been to one of these workshops before, that's a key term that we're trying to use throughout, is being secure in knowledge and understanding. This evening, Mrs. McCormack is going to be leading our EYFS, as she has done for the previous 3, so thank you very much.
Is it the last one?
It is the last one. Counting down the days. Mrs. Bliss is going to lead on years 1 and 2, Mrs. Thomas 2 and 4, and then myself 5 and 6. There will be opportunities for you to take part. There are resources stretched along the gangway. Please feel free to grab some bits and bobs and get involved as much as possible throughout the next hour or so. And a copy of the calculation policy is available. I haven't brought any tonight, but if you would like one, just drop me an email and I can ping it through to you. A copy is also available, it's on the website. If you go through prep and into the maths section, there is a copy of it there that you can access as well. This is an example of the division policy, or division aspect of the calculation policy, and you'll see, teachers will mention tonight, each section, each part has the expectations within the year group at the top. We always begin each section of the calculation policy linking to place value and mental methods of calculation before moving on to the written expectation as well, and how that progresses through the prep. Before modelling different examples, on the right hand side you can see how these examples are modelled, starting with concrete, hands-on resources, representing those pictorially, before then, when secure, moving on to the abstract, and that's when we start looking at numbers, digits, and how we can manipulate those. This is exactly the same for each year group, but differentiated obviously, showing those skills and how they progress throughout. I'm going to pass straight over to Ms. McCormack. Division is taught in EYFS, maybe not as discreetly as throughout the rest of the prep school, but it's still a vital part of children's learning and introduction to divisions. So, Ms. McCormack.
No, it's the last one. Yay! Right, I'll show you the slide that we always start with, which is what the EYFS is. Nursery, transition and reception. It goes from birth to 5 years, and I follow a document which is the Early Years Foundation Stage Curriculum, which is a statutory document that I have to follow their guidelines. So, my children right now in reception are working on their early learning goal. So they should be, in number, solving problems including doubling, halving and sharing. So we look at all of those together at the same time. Some children may still be working within 40 to 60 months, which doesn't really explicitly talk about sharing and halving and doubling, but it will be mentioned in addition and subtraction. And then I also will have children who are exceeding, so they've gone past the early learning goal, and they're solving practical problems that involve combining groups of 2, 5s and 10s, and sharing into equal groups. And this is the bit we're talking about, sharing into equal groups. So the vocabulary is very important, and one of the first things I really have to talk about is sharing, because we do a lot of talking about sharing in EYFS, but we're talking about it a bit differently now. It's a maths vocabulary, and it has a slightly different meaning. Sharing with your friends is a bit different to how we're going to share a set of things into 2 groups or 3 groups. So we talk about sharing, halving, number pattern, equal, same and set. So those words are really important. And a lot of what I teach will be based on practical activities and reinforcing this vocabulary. So it needs to be hands-on experiences. As I've said with all the other different calculations, we don't write maths calculations until the very end of the year. And division is one calculation. We will never see the division sign in reception. We won't talk about it. They don't need to see that. They need to understand what it means through practical activities. So they need to have experiences of grouping and sharing and lots of opportunities to share objects and to use the right vocabulary and listen to the vocabulary that I'm using. So grouping needs to be used equally. So we talk a lot about sharing and equal sets and solving problems. And a lot of this problem solving will happen in our theme corner. So I might say to them, share the flowers equally, how many will each of you have? And it will be a practical activity with me using the language and getting them to use the language when they respond to me. Understand sharing as the same amount. If I'm going to share 6 objects, would you like 4 and your friend has 2? Is that fair? Is it equal? And so, for example, can you share the 6 grapes between 2 people? How many grapes will each person get? So again, I'm using the same vocabulary, but that question is slightly different to the first question. So it's getting a little bit harder in their understanding. I need to keep repeating the vocabulary, giving them lots of practical experiences. And then group objects and count how many in each group. For example, can you put the 6 sweets into 3 groups? How many sweets in each group? So each question is slightly different, and it's getting slightly harder, but they should be able to manage to do those activities practically. So we've just used concrete resources the whole time we go through. So for example, if we've got the blueberries, how will you find half of that set of blueberries? What does it look like? How do you represent that in a picture? And that's as far as we will go when we are talking about division. So one thing I would like to reinforce as we come to the end is in EYFS it has to be practical, hands-on, touching things and understanding what each of those operations means. Don't go rushing into a page of sums and thinking they will understand that. They need to know what each of these processes is and how we get to that calculation, what it means. It looks like this, but what does it mean? Because if they don't understand that, they cannot progress through the other stages. And one thing I would say, as the weather is getting better, go outside and do maths. Pick up things, get dirty. Don't take your workbook outside and sit in the sunshine, but get real things and do maths outside because it will be fun, they will enjoy it. And do you think they'll remember it? Yes.
Right, time for year 1 and 2. So you've got the year 1 objectives at the top from the calculation policy, and then underneath you've got the objectives from year 2. As you'll probably notice, they are very similar. That's because really the difference between year 1 and 2 in division, in year 1 it's still very much we're looking at things practically, we're drawing lots of pictures. The division sign is starting to be introduced, but it's really in year 2 where we start to actually create division calculations. We're using the division sign explicitly, whereas in year 1 it's still reinforcing that practical knowledge of division, the pictures, looking at that way. So if you were listening, grab a whiteboard. What words would we associate with division? You've got a minute, go. Work with a buddy if you like. So what kind of words have we, just shout them out, what kind of words have we got? Got sharing, sets, super, groups, fantastic, divided, good enough, one we're definitely using year 2, Equal parts, fantastic. Again, that one is really, really key, is equal. Because if they don't understand they need equal groups and they don't understand the context of dividing things, of multiplying, and that's one of the big things, is reinforcing equal groups of things. So in year one, again, you've got the showing how they would look at it in year one, and as you can see, there's no, when we get to the abstract, it's not a division calculation. They're still looking at actually outside, we have got 2 hoops. Here are 6 bean bags. Can you share the 6 bean bags between the 2 hoops? Looking at getting them to go and do it, as Miss McCormack said, still very important, go and do. Go and see that they are both equal, both the same. Because they'll notice when you're sharing things, oh, that group is not equal. I need to make sure that is equal. So, similar to multiplication, you'll notice probably lots of things similar to multiplication. We start with the number line. And we start to introduce counting back in steps of 2 and back in steps of 10. And we start to introduce the term repeated subtraction with children. They'll be familiar with it from multiplication, adding, adding, adding again. But then we start to introduce the same concept for subtraction, repeatedly taking something away. Now you can see, very visual on the number line there you can see, I'm taking 2, I'm taking 2, I'm taking 2. And yes, we introduce that and use it with lots of concrete things. We draw it lots, we show it with groups, they're counting back. And again, we talk lots about, in year one, they talk about halving, and the term halving is introduced. And it's introduced, and again, so they'll be familiar with doubling, that's then learning the process. We're halving something, sharing between 2. And then they'll start with just doing halving to 6. Then when they're more secure, they'll move on to halving numbers up to 12. And again, it will start to be linked in, oh, patterns of 2, hopefully, because they'll recognise it from when they've been counting into. So, and then we move on to the concepts of grouping objects and sharing objects. And so you've got 2 little kind of examples up there. So we're drawing on, so for grouping objects, we're drawing on their knowledge of arrays, putting things into groups of objects, using concrete objects, using sets of objects. And then when sharing, beginning to halve different quantities, showing that we're separating things. And then representing division in equal ways, but still understanding it is equal, both the same in each group, whether we're making sets of 5 objects or whether we're sharing 5 objects between groups, so understanding it's the same. So you've got your first problem there for you. So with a pen and a whiteboard, how would you work out the following problem? How many towers of 3 can I make with 12 cubes?
Feel free to take the cubes.
Yeah, feel free to take the cubes in the box. How many towers of 3 can I make with 12?
Again, being hands-on, concrete producers.
Right, has anybody very quickly, have we got to an answer? How many towers of 3 can I make if I have 12 cubes? Lovely Mrs. Potts, she's got a nice visual representation there. She's got her 4 towers. Super. So again, as you can see, the children, they've understood they've got their 12 cubes, they've shared them, they've made towers of 3. They can understand that my 12 makes 4 towers of 3. The teacher in class might then say, oh, 12 divided by 3 equals 4. And start to introduce looking at it like that calculation. So, and another question for you, our favourite diagnostic questions. And some of these questions, it throws up misconceptions for the children. So what is 8 shared between 2 equal groups? Some of those answers will be a misconception, and see if you can figure out why would some of the answers be a misconception. Why might a child think the answer is 10? Something to think about, something a bit different. Super, so they're thinking, so 10 might be a misconception because they thought, oh, 8 add 2 equals 10. Super. And so what is the actual answer? Charlie? 4. Super. So sharing 8 between 2 equal groups, but also it's good, these questions throw up any misconceptions of children, i.e. 8 add 2 is 10, they're using their number bonds, they're not thinking about sharing equally. Super, then we move on to year 2, and as you can see we're still very much focusing on concrete resources, but we tend to focus more heavily on using repeated subtraction, showing things on a number line. We still do lots of work with sets of objects, groups of objects, but we start to use number lines more heavily in year 2. So this is something I like to do with the children. When we're starting division, we draw a big map together. We look at sentence stems, which are sentences that help children create their answer, i.e. blank has been shared equally between blank equal groups and blank in each group. It's a sentence they can use. You can give them objects. They've got the sentence, they can talk about it without saying, oh, I can't remember, what are those words I'm using? They've got the sentence, they can fill in the blanks. So we gain a more secure understanding of halving numbers in year 2, of halving numbers up to 40, and hopefully as we introduce multiplication in year 2, they should start to see the pattern that halving is the 2 times table and the both are interlinked. We're expected to learn halves of multiples of 10, so the 10 times table halving those numbers as well. And also the term commutative is also reintroduced as well. The understanding that multiplication and addition are commutative because they can be done in any order, but making sure the children understand that division and subtraction are not. So they have to be done in one set order. We do it all the time in year 2. We deliberately put things around the wrong way and we can see we can't do it because in subtraction we haven't learnt about minus numbers, or in division we can't share that number equally. So just learning that it has to be done in a set way. And then we build upon sharing and grouping, and then we also start to link in division facts with multiplication facts, learning that 2 times 2 is 4, 4 divided by 2 is 2, relating those facts together so that they can start to get more fluent in their fact knowledge. We also do lots of practical concrete methods. We still share objects, we still make arrays, still doing all of those practical things to reinforce our knowledge. So, how many towers of 5 cubes can I make with 20 cubes? So another cube question. And again at the bottom, it's just asking them to understand the relationship between the multiplication and the division. So blank times 5 is 20, 20 divided by 5 is blank. So they can start to understand the pattern. So have a go. Maybe.
So, 20 cubes is 20. What are you going to do with it? How many towers of 5? So how many cubes are going to be in each tower? How many towers of 5? So how many cubes are going to be in each tower? How many towers of 5? How many towers of 5? So how many cubes are going to be in each tower? Just said it. 5. How many of those towers can you make? Have a look. Say, show me.
Right, so have we got anywhere? So how many towers of 5 cubes can I make with 20 cubes? Lovely, Mrs. Payton. Super. And then also who can say to me, what times 5? Adam, can you finish? Super. 4 times 5 is 20. 20 divided by 5 is?
5.
No, 20 divided by 5 is?
4.
Yes. So again, as we highlighted just there talking with Hannah and Adriana, sometimes they really need to reinforce how many towers of 5 cubes. So how many cubes are going to be in a tower? And it almost then feels like a trick question. It's just reinforcing, no, there's going to be 5 in each one, understanding those equal sets. Super. And again, something we really start to focus on is we focus a lot on solving divisions by looking at repeated subtraction. It's not as complex as it sounds, and actually once we get into a habit of it, it's quite simple. And so when you're division, the number used, so you're working it out and you're just counting the jumps back, and that gives you your other number in the division sentence. So you can see there, 9 take away 3, take away 3. So 9 divided by 3 is 3, because we've had to do 3 jumps back to get to 0. And that's how you're doing the repeated subtraction. You're doing jumps of 2s, 5s, 10s, 3s till you get back to 0. Then you're counting how many jumps you've done to give you that other number in the division sentence. And here you go, some more diagnostic questions. Again, something just to look out for. Again, these questions will throw up misconceptions that the children may have about division, helping teachers to highlight and reinforce that knowledge. But feel free, have a go. So Holly has 20 balloons for her party. She wants to hang them in pairs. How many pairs will she have? Other way round.
How many groups of two?
Could you show me 0, 1?
Get them into twos. Give them to Charlie when you get a group of two.
Super. So how many pairs of balloons will she have, Adam? 10. She'll have 10 pairs of balloons. So you can share 20 into pairs, and children in year 2 should know that a pair means 2 things, because hopefully in reception and EYFS they will have done lots of work on pairs. And second diagnostic question, which calculation can complete the number sentence? And this is something we're looking at lots with the children. The answer comes first, then it's the calculation. And again, it's just to reinforce showing them calculations can look differently in different situations, and getting them to understand that we're not looking for another answer, because children get into the habit, they see the equal sign, they want to write an answer. They don't necessarily want to think about, oh, actually, it's flipped around, it's in reverse, I need to think of a question. So what could the question be? Have a look. What could the question be? The answer is 4. What could be the question? Any parents want to venture an answer? Anyone? C? Why do you say C? Super. So she's recognised commutative. The bigger number is first. So it can't be 2 divided by 8 because we cannot share 2 cubes between 8 people. Super. So 8 divided by 2 equals 4. Lovely. And I think that is the end of year 1 and 2.
Okay. Now things are getting serious. Year 3 and 4. So hopefully by year 3, children have mastered the vocabulary. They understand what halving, doubling, equal, sharing, pairs, sets. And then, if you take a look at the objectives, they are really identical between year 3 and 4. The difference is in numbers. Numbers get bigger, and when number gets bigger, problems get a little bit more complicated. But it is still the same objective, just trying to apply different methods, more advanced methods, more abstract methods, and working with different numbers. So in year 3, we start with concrete, which can be, as it said here, a lolly sticks. Counters, anything they can put their hands on, because it is still important, even in year 3 and 4, that children do manipulatives, that they actually understand what division means. So they can build, so 2 digits, for example, the question here is 13 divided by 4. As you can see, it gets more difficult because we have reminders. You get to year 3, suddenly it doesn't have to be just equal groups. There might be something left over. So how can you solve it? For example, sticks, counters, and they can put these objects into groups, so they can actually see what happens when you divide them into 4 equal groups, and 1 left, your answer is 3, remaining 1. And also, you can reinforce their knowledge of shapes, because if they're using sticks, you can at the same time say, what's the name of that shape? 2 things in one go. Then pictorial representation, doing the same thing, but now going a step further, maybe drawing a shape, or just drawing counters of whatever is easier for a child, and getting the answer. And the abstract in year 3 is the number line. And we start at the end. So we draw a number line, we write 13, because it's 13 divided by 4, and then we count back in steps of 4. So if you go 4 back, what is the answer? What is 13 take away 4? It's 9. Then you count in steps. So again, it's a repeated subtraction until we get to the answer. So they can use different methods, and this is a progression. So some children will start with concrete, move to pictorial, and then master abstract. In year 4, it slightly changes. It becomes it's a big step in year 4 in terms of abstract method. I'll get to that in a moment. Concrete, again, they can use, and I home if your children are stuck, and counters are really great for this. And earlier, years 1 and 2 in reception. So we made these sheets and laminated them. And so, for example, if the question is 42 divided by 3, or any other number, there are two ways of doing it. You can take 42 counters, one standing for 1, and you can start, and for example, the question is divided by 3. So this is how many places you have to divide, groups you have to divide them. So they can go 1, 2, 3, 1, 2. They keep doing it until they share them equally, or if there is a reminder, they can understand that there is, or they can use it like this. So this can help them with multiplication and division as well. So just to be able to actually understand what happens when you divide equally or sometimes not equally. Victoria is not different. You do the same thing, but now you have a bit more confidence to actually draw it yourself and come up with a method yourself how you want to do it. Abstract, this is where they can stuck a bit sometimes. And for some children, it takes a little bit of time to move and understand the abstract method. So 42 divided by 3. So we use what they call a bus stop method, that's how it's known. And then what we do is we apply our knowledge of counting in tens, so multiplying by tens, dividing by tens, because this is something that by year 4, children should be secure with. They should know how to count in tens. They should know there are 10 tens in 100 or 5 tens in 50. So they look at 42 divided by 3 and say, how many tens divided by 3, and they say 3 times 10, because they're dividing by 3, is 30. Take away from 42, what do I have left? I have 12 left. What then, when I divide 12 by 3, what do I have? 4, and that's the answer. 10 add 4 is the answer, 14. They do find it confusing, and one really good way to help them understand it is using money. So what we had last term in our class, we had a situation with quite a lot of children when we were faced with this. They were just not, but why do I add 10 and 4? But why don't I do 10 and 3? And there was a lot of confusion. So what I did, and it really helped some of them, is I used a very specific life example, something they deal with in life. And so I took a child and said, you have 42 pounds, for example, and I made 4 10 pounds for her, and made 2 pounds, like pound coins for her, and said, here are your 3 friends, can you share it equally between those friends? So then she went 1, 2, 3. She gave everybody 10 pounds. Then I said, look how much you have. Can you go again? And and she said, no, I can't. I have only 12 left. So you can't go in tens anymore. No. So what can you do to share it equally? And she said, I can exchange it for £1 notes. And that is actually what they need to understand, is exchanging from tens to ones. And then when she exchanged it into £12 coins, she understood that if she has 3 friends, each get 4. So it's actually using real life experience is something they can get their head around, like money, like £10 notes exchanged for £1, to understand these problems. And then eventually the understanding settles in. Why 3 times 10, and then why 3 times 4. But it's about exchanging from tens to units as well. So in year 3, another method is again doubling and halving. They need to understand, they have to have knowledge by this point, mostly 30 divided by 2 is 15, and then what's left over is 6 divided by 2 is 3, and also they can use the bar model to do the same. So it's basically using knowledge to build in year 3 about the place value knowledge of numbers to divide them, to double them and half them. In year 4, exactly the same, but what's the difference? The difference is the number is much bigger. So at this point, it is about knowing that 300 divided by 2 is 150, 40 divided by 2 is 20, and 4 divided by 2 is 2. Some children who have more secure knowledge will immediately know that 340 divided by 2 is 170, because, and that's when we use the place value knowledge, and we always recall, when you say, what's that 340 divided by 2, they go, oh. And you say, what is 34 divided by 2? And then, oh, 17. So 340 divided by 2 is it's 10 times more, so your answer needs to be 10 times more, so it's 170. So they partition it either into 2 or 3 steps, depending on how secure they are with their knowledge of partitioning. So, half 276 using your knowledge of place value, parents and children.
So what's half of 6? 3. So the tricky bit is working out what's half of 17. So what's half of 2? What's half of 2? 1. So what's half of 10? Half of 10 is going to be 20.
Do we have any
so half of 200
volunteers?
is going to be...
It's still working.
Don't get all shy on me, have no more.
There's a conversation, interesting debate going on there. Okay, do we have any volunteers who would like to tell us what is 276? Half. Half of 276. You can start getting dojos for this.
Half of 200 is 100.
Yes.
Half of 70 is 35. And half of 6 is 3. So
And
it is 138.
138. Did anyone take different steps, or did you all use exactly the same steps to halve? So you used 3 steps. You went to 200 and 270, then 6. Excellent. Good effort. Did you have your hand up? Did you have your hand up? What did you want to say? Did you? What did you get? Oh, this is blind. I have to close it. 138. How did you get 138?
Because all we did with half of 200 is 100, half of 30, half of 7 is 70, is 35, and half of 6 is 3.
Well done. Excellent. Excellent. Grouping is another thing. So in year 3, we continue to tell them that 16 divided by 2 is not the same as 2 divided by 16, while in multiplying they can, addition they can, division and subtraction. We already went through it, so we just continue. We just maybe work with different numbers, but it's always good to reinforce it. And when they get confused, because they will get confused, again, get them to say, they say, okay, they're solving a problem and they say, oh, I need to say 2 divided by 16. Then you say, can you take 2 and divide it by 16? And then they go, oh. And realize that that is not the right way of doing it. So even in year 4, using counters and just manipulators, it's really, really good. And then they are taught to use inverse operations to help them solve missing numbers. We already had similar question to this. So what number times 5 is 30? It's the same calculation as 30 divided by 5. And to divide multiples of 10 using known division facts, I already touched on that when we talked about divisions earlier. 240 divided by 8 is 30. How do they know that? Because at this point, they should be really secure. And I'd like to reinforce this as timetables. It's really important for their confidence, for their fluency, to know their timetables, because you have children who actually have a great mathematical ability and they are able to solve problems, but they get stuck because the amount of time they spend to try to figure out 3 times 7 is, by the time they realize that they forgot what the question was and they lost their confidence. So timetables are incredibly important, especially when we move to year 4, when the problems become longer, slightly more complicated, and having to do this isn't helping. But if we know that 4 divided by 8 is 3 because we know our 8 and 3 times tables, then we easily know that 240 divided by 8 is 30. Grouping, again, 45 divided by 3, 3 lots of 10, 3 lots of 5, they make 45. We can just move on because this was already explained. And they know to find multiples of 10 to begin with before finding any remaining. And problem should be set up correctly, which means that you start by multiplying once, so 3 times 5 is going to be 15, and then you count in tens until you get to 0. So you're going back again, you're counting back from 45, starting with units and moving on to tens. And then when they're secure, we already said, so we've already been through this problem on a previous page, but if we just go step by step now. So 72 divided by 3. So 3 tens, this is a different number, so you will have several steps here. So 3 times 10 will give us 30. This is the number we use when we used money, because there were 2 times that she was able to give out £10 notes. Then you go again and say, what do you have left? 43. 3 times 10 is 30. What do we have left is 12. And then 3 times 4 is 12. And once you have zeros left, you have your answer. And the answer is the addition of all these numbers that are multiplied by 3. So they have to add 10, add 10, add 10, add 4 is 24. And this is something that even some really good mathematicians in our class took time to understand. And it's important, again, to try to reinforce it with examples so that they then get their head around it and become more confident and understand why they have to take these steps. It's called chunking method. This is basically what we are working towards in year 4, that they all develop, most of them develop ability and confidence to use chunking method to solve divisions. So parents, use the chunking method to solve 92 divided by 4. Mrs. Proctor is one to beat today.
You're saying words to me now that I can stop.
Multiples of 10 first. So here, you might not need to do 10 times 3 times 3. You might immediately be able to go 20 times 3.
It's like my sister-in-law. She did a maths degree. I remember one day after she finished at 5, getting into it, they had these back review and reading number. I just started to look at all of these things like you need to start to just blow my mind. And she's done all of this because she did a skill.
So, what is 92 divided by 4? 23. Mrs. Baxter, can you tell us, how did you get 23?
Okay, so we did our bus stop, we did 10 times 4 is 40, so that's away from the 92, gave us 52. Did another 10 times 4, 40, take away 52, gives us 12,
question. The question was, why do we have to go 4 times 10 if, for example, I can already see, or a child could already say that you can put 20 in? The reason is you can't always count in 20s. Sometimes the 10 will be the only step you can take before you get to ones. So it is important that they build this confidence to build it up and see how many 10s go in. And eventually, when they become secure with it, they're actually, and then I think that's moving to year 5 and 6, and Mr. Woodward will talk about it, they will be able to use more advanced method. But this is expected for year 4 to be able to do it this way. Some will go beyond it. And that was year 3 and 4. As you can see, it gets a bit more complicated.
Thank you very much, Ms. Thomas. I'm going to touch on chunking again in a minute, and we'll kind of expand. You can see how this goes on to 5 and 6, and we'll have more examples that we'll go through later. Initial objectives for years 5 and 6, it's all on the calculation policy, so I'll let you have a look and see. And as normal, we can see the concrete, pictorial and abstract methods that are used within 5 and 6. They are exactly the same in 5 and 6, whereas, as we've spoken about before, year 6 is consolidation of that learning and being able to use and apply this knowledge across a range of contexts. So that then by the time they leave the prep school, by the time they reach the end of year 6, they are secure with their understanding and able to transition over to senior school. So we continue in year 5 with halving, and we looking at context, and I know that Mr. Thomas mentioned about monetary context as well, really important. And we also touch on decimals as well, and that decimal notation. We look at halving whole amounts, £14 for example, and halving that, and halving pence as well. Now, by this time, some children may not be as secure and want to halve 80 pence and halve 4 pence. Some children might be ready just to halve 84 pence and then give us an answer of 42. Give us an answer of £7.42. And it links in the same as when we're doubling, we're multiplying by 2. For those of you at the last session, would have seen something very, very similar, and doubling £14 to £28. Here we're halving and using exactly the same process. Dividing by 10, 100 and 1,000. Again, those of you who came to the last workshop will know when we're looking at multiplication, what happens when we multiply by 10, 100 and 1,000. When we multiply by 10, our digits move 1 place to the left, our numbers are getting larger. When we're multiplying by 100, our digits move 2 places to the left, getting larger. And when we're multiplying by 1,000, our digits move 3 places to the left. Our numbers are getting larger. The values of these numbers are getting larger. With division, it is the inverse, and a key word throughout the whole prep school is the children understanding about the inverse operation. And this is the inverse operation here. So when we're dividing by 10, the digits move 1 place to the right. When we're dividing by 100, the digits are moving 2 places to the right. And when we're dividing by 1,000, the digits are moving 3 places to the right. And a good way of remembering this and teach children is to look at the number of placeholders within 10, 100 and 1,000. In 10 there is 1 placeholder in our ones column, so we move 1 digit, either to the left or to the right, depending on whether we're multiplying or dividing. 100, 2 placeholders in the tens and the ones column. And so we know to move 2 places, either to the left or to the right, depending on whether we're multiplying or dividing. And the same when multiplying and dividing by 1,000. It is important still to know that the decimal point doesn't move. Okay? We don't just take away 2 zeros when we're dividing by 100. The same as we don't just add a 0 when we're multiplying by 10. It's really important for children to realise that's not the case, because as we spoke about last time with multiplication, and as we'll talk about now, when we come into looking at decimal notation and decimal numbers, we can't just take off a 0. We can't just take off 2 zeros, because that doesn't necessarily equate to the correct value of the answer. That leads into a whole misconceptions. So the decimal point never moves. So can you please divide these values by 10 to 100? Can you please use a place value grid? So can you set up a place value grid like this on your whiteboards, please? And can you divide 630 by 10 by moving your digits 1 place to the right? and then dividing them by 100, by then starting from 630 again, and moving 2 places to the right. And then can you do the same with 27 for me? Off you go. I'm going to give you 1 minute or so, because I'm going to crack on because of time. So start with a place value grid to get you started. Should be one. Oh yeah, I have changed that. Sorry. Well, this is cocktail.
Yes, well done.
What happens when you turn up to all four? What Mrs. Thompson doesn't know is her and Mrs. Morehouse are going to be So we put it as 0 to represent 1. So you all ones. The idea is to make sure it's 0. Doesn't show you don't manipulate the values. The idea is to make sure that you're secure rather than just being skill. Anyone can use a skill before you actually understand. Teach a skill, oh, when you've got 30 by 10. Learn a skill, it doesn't really tell you what's happening. So 630 divided by 10, anyone, when we move our digits 1 place to the right, we get Mrs. Payton. Then 63. Now, dividing by 100 is the same as dividing by 10 and dividing by 10 again. So we could do this one of 2 ways. We could go back to 630 and move our digits 2 places to the right, giving us an answer easy of, so I'll put you on the spot. 630 divided by 100 is 6.3. That's where we get into our decimal notation. Or we could divide by 10. 630 divided by 10, we've already said is 63. And then divide by 10 again, which again still gives us an answer of 6.3. So we still get the same answer whether we divide by 100, moving 2 spaces, or 2 lots of 1 jump. 27. If we divide by 10, gives us an answer, Mrs. Morehouse, of 2.7, so you move your digits, just the same, we're quite lucky actually with 23 here, it's very similar. You move your digits 1 place to the right, so if we move my 3 ones 1 place to the right, we now have 3 tenths. If I move my 2 tens 1 place to the right, I've now got 2 ones, I know it says units there, ignore that, thank you Mrs. Proctor. Gives me an answer of, so that's 2.3, this will give us an answer of 2.7. And if I want to divide by 100, go back to 23 again, move my digits 2 places to the right, so my 7 ones that would be here, I move 1, 2 places to the right, giving me 7 hundredths. My 2 tens, I move 2 places to the right, gives me 2 tenths. But I've got a problem, and that is that there is nothing in the ones column. Now, children are taught there always has to be something in the ones column. In this case, it represents nothing. There's nothing there, so we represent it with a placeholder. We represent it with 0. Giving us an answer of 0.27. We can't just leave it blank. Okay, we can't just put 0.27. Okay, 0.27. We need to represent that whole number with a value. In this case, that value is nothing. Children using multiple division facts to help them to mentally solve problems. So again, this kind of leads on from what's been taught in year 4, knowing that to solve 3,600 divided by 9, we need to use our division fact, our known division fact, knowing that 36 divided by 9 is 4. There are 4 lots of 9 and 36. So 36 divided by 9 is 4. Then 360 divided by 9. 360 is 10 times larger than 36. So our answer on the other side of the equal sign is going to be 10 times larger as well. And 3,600 divided by 9. Again, 3,600 is 100 times larger than 36. And so that means our answer is going to be 100 times larger on the other side of the equal sign. So we're making sure that we balance each side of our equal sign. Again, so important for children to realise that the equal sign, yes, it gives us an answer after it. Year 2, perfect example, when they spoke about the answer, or 4 equals, what's the question? Yes, it's flipping round the answer and the question itself, but what we're trying to instill in year 5 and 6 going forward is actually that equal sign means that both sides need to balance. So yes, we've got 36 divided by 9 on this side, and we've got 4 on the other, and the reason why that works is because both sides balance. And that works really well when we get into calculations where we have 36 divided by 9 equals something times 2. And so children automatically will put, well, 36 divided by 9 is 4. So it's 4 times 2, but both sides don't balance there. And it's difficult to explain without writing it down, but it's something that I want to go on to next year, hopefully, when I do something different. But it's really important that children understand what that equal sign actually means as well. Can you have a go here? Use your known division facts here to solve these problems. So the first example here, what division fact will you need to know initially to be able to solve 4,500 divided by 5? Can someone tell me? What will you need to know to begin with? 45 divided by 5. If you know 45 divided by 5, then you can use that to solve 4,500 divided by 5. Do the same here with B, 810 divided by 9. What division fact will you need to know, Mr. Kirk, to start off with? 81 divided by 9. If you know 81 divided by 9, then you can find the answer to 810 divided by 9. And 48,000 divided by 4. We're getting really big now, aren't we? Mrs. Morehouse, what division fact will you need to know to start with here? 48 divided by 4. And if you know 48 divided by 4, then you can use that knowledge to solve 48,000 divided by 4. Here we go.
You can do that, are you sure? Even though you shoot. I know, I think I'm okay. You talk about related facts and I think I'm okay now.
We've looked at equations in algorithms introduced in really understanding that letters can represent numbers, that sort of thing. It's just a different representation. Do I do workshops? Yeah. So 4,500 divided by 5. We know 45 divided by 5 is 9. So 4,500 divided by 5 is, Sam, come to you. 900, yes, excellent. 810 divided by 9. Mr. Kirk told us that we needed to know 81 divided by 9, which is 9. So, Claudia, so 810 divided by 9 is going to be 800, so we know 81 divided by 9 is 9, so 810 divided by 9 is 10 times larger. Stage fright. Let's go to older sister, Lara. 810 divided by 9 is going to be... 90, yes, thank you. And we know that 48 divided by 4 is 12. So 48,000 divided by 4 is 1,000 times larger than 12 is going to be, Charlie? 12,000. Fantastic. Well done. Now, chunking. Mr. Thomas touched on this a minute ago. We're going to have a look at another example, and this is how this progresses from year 4 through to year 5. So as we can see here, we've got a larger value now, 326 divided by 6. Notice at the moment we're still dividing by a single digit. That's important. It's important because children need to be secure with this understanding, this knowledge. So we start by writing the calculation, and we look for known multiplication and division facts that we can use to help us. So our first chunk, what we try to teach children is to start with multiples of 10, multiples of 100, multiples of 1,000 to start off with. In this case, we know that 5 times 6 is 30. So we can look at 50 times 6 being 300. And hopefully at this point, when we're going back to here, hopefully this knowledge is already embedded, ready for them to be able to use and apply. So 50 times 6 is 300. We also teach children how important it is how to present these calculations as well. It's really important that it's presented properly, making sure that our subtraction comes directly below the value that you start with, so that there are no misconceptions in terms of place value, as we've spoken about with subtraction before, and our chunks are on the right-hand side here. This also needs to be presented properly and needs to be done in a certain way. Our chunks should come first, and we're multiplying by 6. And if we continue, we know that 326 taken away 300 is 26. Notice how, again, place value is really important here. Now, 4 times 6. Notice how we've got 50 times 6, 4 times 6. If I didn't care about my presentation, the way that I was presenting it, and wrote 50 times 6 and then put 6 times 4, what could be the misconception that we get here if we do it that way? Lara? Because we've been through this a million times.
You could add up the 50 and the 6.
You could add up the wrong chunks. So you could add 50 and 6 by mistake, which isn't going to get you to the right answer. Okay, so we need to make sure we're setting this out properly, making sure that our chunks are in line and presented the same way as we're going through, using those known multiplication facts. And this gives us a remainder of 2, giving us an answer of 50, our first chunk, 4, with 2 left over. Now, if we go into year 6, we can convert those into decimals, we can convert those into fractions. Okay, we'll leave that for another time. Okay, I don't want to bring in any misconceptions now. But that is a basic level of chunking. But the way to be able to do this and understand this is that children need to know those known multiplication facts. And it is now a national expectation, but by the end of year 4, children need to know all of their times tables up to 12 times 12. It is a national expectation. It's an expectation that we need to meet here as well at Radnor, so that children are able to take this learning forward and able to solve problems like this using those known multiplication facts that they have already. In terms of chunking, Mrs. Thomas touched on it. It is tricky. Once it clicks, it clicks. But so it takes a few examples just to get through. Can you have a go at this one for me? See how you get on. If you've got any problems or you're not sure about anything in terms of presentation, in terms of your chunks themselves, please put your hand up and I'll come and give you a hand. I'll give you a couple of minutes on this one. Have a go.
They were asking, they didn't send this is why I need to calculate. You need to teach probably, yeah. Way back in 2018, I beat my son once.
Just going to talk about a couple of examples I've got here. 2 examples, both get the same answer, worked out in different ways using the chunking method. And neither of these are wrong. It depends how confident you are. When we speak about confidence, we've just been talking about how confident children are and whether they're ready to move forward. I've got 2 examples here. I've got Lara's example here. Now what Lara has done is she's created a chunk of 50 lots of 3, and she's taken that away from 243 to leave her 93. Then she's done 30 times 3, which is 90, leaving her with 3, and then 1 lot of 3 is 3, and added her chunks together to get an answer of 81. So there are 3 steps involved in that chunking: the chunk of 50, the chunk of 30, and the chunk of 1, giving her an answer of 81. Now, we've got another example here, where instead of doing the chunk of 50, the chunk of 30, and the chunk of 1, we've got a chunk of 80 and a chunk of 1. And it depends on how confident you are. Both of these answers both of these ways get to the same answer. It's just that Lara's method required an extra step, whereas this has been completed in 2 steps. Lara's needed an extra step, an extra calculation, but they both got to the same answer. And Lara's method and Penny's method, nothing wrong with them at all. Both of them get the same answer. It depends on how confident you are with those multiples of 10. Now I know that if Lara went through this again, and as soon as she saw this, she would have said, yes, I know that 8 times 3 is 24, so 80 times 3 must be 240. So it's dependent on how confident you are, and the more that we practice, the more confident we can get. But there's nothing wrong with either of those methods. They both get to the same answer. So, in Year 6, children continue to use chunking to make sure they're secure, as you can see here. Then we go on to look at thousands digits, and we try not to. We're hoping that by the time children come into Year 6, that they are secure with chunking and that they are able to solve these calculations. So when we're looking at 1,000 digits, again, notice how it is still dividing by a single digit. It's important, and we'll talk about that in a second. Children, look at those no multiplication facts here. So finding that 1,000 times 6 is 6,000, 200 times 6, 60 times 6, and 4 times 6. Now, that I've done, and it seems a quite straightforward method, because I've looked at multiples of 1,000, then multiples of 100, multiples of 10, multiples of 1. It's worked that way. Sometimes it might not be like that. Some children might need to do 500 times 6, 500 times 6, 200 times 6, or maybe even 100 times 6, 100 times 6. As we've just said, and as we've just found out, you get to the same answer. It might take you a little bit longer, but when you become more secure with your understanding, then that will speed up and you'll become a lot more efficient. But this is how we start Year 6. But then, once children are secure, this is when we look at short division. Once we know that children are secure. And this is where we can solve the same calculation, knowing that 6 into 7, as it were, we know it represents 7,000. And this is why we do chunking first, so then children understand what those digits represent before they race ahead onto here. And the problem that I have, especially with division, and why I think this is so important, is the number of children who come into Year 4, Year 5, using a short division method like this and having no idea what any of those digits represent when they're working it out. It's 6 into 7 goes 1. Well, that doesn't represent 1, it represents 1,000. It's understanding that. And then there's 1 carried over. Well, it's not 1 carried over as such. It's 1,000 carried over. And we can see that here. It's 1,000 that is carried over. And children need to understand that. It's the same with multiplication and grid method, the same with addition and subtraction, and children understanding what those digits represent. So if we don't want to race to this. This is the end goal. And by the time children leave year 6, this is what we want children being secure in, because that is what they'll use in the senior school. They need to be efficient and use those methods. But what I want, as a maths leader in the school, as I know that the staff want, and I know what the children want, is they want to be secure in what their understanding of these numbers represent, and not just racing ahead to the finish line. Now, chunking, we move forward with. So this is our end goal when we're dividing by single digits. When we look at dividing by 2-digit numbers, we go back to chunking again. We go back to chunking. And we start with a help box. And the reason why we use a help box is because, I don't know about you, but I'm not the most fluent when it comes to my 17, 18 times table. Now, if some of you are, you're better than me. Fantastic, well done. But what I want children to be able to do is to answer these questions securely, confidently, and the way we do that is by using our multiplication knowledge. Anyone can use a help box and can solve any problem using a 2-digit number. We all know 1 times 15 is 15. If we know 1 times 15 is 15, we can do 2 times 15 by doubling that. If we know 2 times 15, we know 4 times 15 by doubling that. We leave 5 times 15 for a second. We'll go straight on to 10 times 15. We know how to multiply by 10, the digits move 1 place to the left. And if we know 10 times 15, then we can halve 10 times 15 to give us 5 times 15. So straight away, you know 5 parts of the 15 times table. 5 calculations within that. And we create that help box. And that help box is used then in a chunking method like this. So I know, when I'm solving 1,905, I know 100 times 15 is 1,500. I know 2 times 15 is 30, so 20 times 15 must be 300. I know 5 times 15, because it's in my help box, is 75. And I know 2 times 15, because that's in my help box, is 30. And this is how we can use this method, the chunking method, to even solve calculations as difficult and as tricky as this. And we can do that with when we're divided by 23. I know 1 times 23 is 23. And if I know 1 times 23, I must know 2 times 23, which is 46. And if I know 2 times 23 is 46, I must know what 4 times 23 is, which is, anyone? Double. 2 times 23 is 46. So 4 times 23 must be, is 92. Yeah, and so on and so forth. So, can I, race right over there. We've only got a couple of minutes left, so I've got some problems here. This will all be on the bulletin. If there's anything you want to talk to me about afterwards, then please do. But I've got some problems here. This will be a perfect opportunity here to test that knowledge. We've got eggs are put in trays of 12. They're each in trays of 12, and they're packed in boxes. Each box contains 180 eggs. How many trays are there in each box? The calculation would be 180 divided by 12. So we're not smaller than the big numbers that we're used to, but this is a question for the end of expectation at the end of year 6. So have a go at this one for me. See how we get on. Oh, sorry. So I haven't actually worked this out. How many trays would there be in each box? 180 divided by 12. Anyone? Charlie, you got it? 15. Excellent. Okay. I'm taking your word for it, so I haven't actually worked this one out. Okay. Then we've got one more. Now, this is a bit trickier. how many boxes of 40 matches can be filled from 2,688 boxes? Or 2,688 matches. Please notice the key phrase there, can be filled. So whatever you have remaining, give you a bit of a spoiler here, whatever you have remaining, obviously you can't fill a box with those matches. So you want complete boxes. And here is where you can use that chunking method, use your help box to start you.
I've done 4 times.
6 times 4 is 20.
40 times.
No, it's not. 6 times 4 is 20.
I'll take your word for it.
So when we've added all our chunks together, we get an answer of Miss Beckerson.
67 remainder 8.
So would the answer be?
67.
So it'd be 67. If you put the remainder 8, that would be incorrect. Because the question says how many boxes can be filled. And this is what tricks children. And this is why we focus on reading the question carefully. How many can be filled? 67 can be filled. If you have remainder 8, those 8 matches can't be placed into a box. So that can't class as being a full box. Okay, right. I have whizzed through those last ones. I just want to finish by saying thank you very much for coming. For those of you who've been to all 4, thank you so much. The reason why I've done this is because I want you all to be confident in the way that we are teaching maths in the prep school. I want your children to be confident as well. I want them coming home and saying what they've done. I want you to be able to say, yeah, I remember doing that, and I'm able to help at home in case there are any misconceptions and they get stuck. The reason why we film these is so that you can come back to these at any point. Other parents can also see this as well, and these will be on the parent bulletins as well, as will all the presentations themselves, so you can see these at any time. So please feel free to look at these at any time that you can. Hopefully you found these engaging and worthwhile. If you have any questions going forward, I don't want you to feel just because these workshops are finished that we stop here. If you've got any problems, any queries, any questions, no matter how small, whether it be via EYFS, straight through to Year 6, please get in touch with me, as well as your class teacher, and hopefully we will be able to, as a team, be able to support you in helping you feel a lot more confident in teaching of maths going forward. This has been the first set of workshops that I want to run. Next year I want to do something different. Hopefully we'll see you again next year, and then we will come back to these at another time. Maybe if you've forgotten, in a couple of years we'll do a refresher course if we need to. But thank you so much for coming. This wouldn't be the success it was if it wasn't for you. So thank you very much, guys, and have a lovely rest of the evening.